Welcome, ladies and gentlemen. You are all on the web. Okay, let me start this webinar, which is an international one. So for some of us is just afternoon, from some other is perhaps early morning or late night. I hope not so late to be already sleeping. And I thank you everybody to participate in this convention. And tonight our theme will be Inositols in Polycystic Ovary Syndrome, an overview on the advances. The participants of these seminars come from 70 countries, and so it's very, very, let's say, emotional to have this all or almost all the world around here, around the theme on inositol this afternoon. And we are happy to offer our last advances in science and in knowledge about the inositol action and their use for treating polycystic ovary syndrome. With me, there will be two other speakers, which are Mariano Bizzarri from La Sapienza in Rome. It is from the Department of Experimental Medicine, and in particular is a chief of the system biology. And the other one is Zdravko Kamenov from Sofia, Bulgary, which is professor of internal medicine there. And myself, which I am Fabio Facchinetti, chairman of OBGYN here at the University Hospital in Modena and Reggio Emilia University in Italy. So before we start with the knowledge advancement and the scientific presentation, I would let Mariano to talk about something about this newborn, this new experts group on inositol in basic and clinical research. Please go ahead, Mariano.
Thank you. Thank you a lot, Fabio. I am just starting with my presentation, and I hope that you can see now the slides.
We are
already working. Okay. Okay. Hi, Kamenov. How are you? Fine. I hope so. Well, let me to introduce this question by recalling that our last paper published on expert opinion about the role of inositol play in many different conditions, but especially focusing on the critical effect recorded in the last 20 years of inositol supplementation in gynecological disease, mostly on polycystic ovary syndrome, prompted a number of scientists, many of which are, I assume that are present at this webinar, to reconsidering in a more, let's say, organized view, a more systematic view, the role that inositol play in both physiological and pathological condition. In order to address this complex, this challenging task, we decide to invite a number of scientists that have spent a lot of their work in investigating inositol and inositol metabolites in order to frame a different approach to provide for the general audience a different appraisal of the critical role sustained by inositol in many different conditions. Therefore, the EGOI, I mean the expert groups on inositol in basic and clinical research, was built. I would like to thank you our common friend, Professor Vittorio Unfer, for this idea and for supporting the web and the organization work that is mostly now organized and developed by one of my former co-workers, Dr. Simona De Nicola. As you know, inositol historically has been considered as a key factor in gynecological and endocrinological pathways. However, in the last 10 years, compelling evidence emerged that suggests that inositol is, as we will see, involved in many other pathological conditions. One specific aspect should be outlined there, and I assume that Professor Facchinetti, as well as my friend Professor Kamenov, will discuss it in more details, is the relevance of some isomer of inositol in some pathological settings. For instance, inositol has emerged as an important player in neurologic and Alzheimer disease, but in our most investigated field, I mean in gynecology, the challenging task is to ascertain what is the proper ratio in between myoinositol and dichiroinositol in performing some critical role in order to ensure the proper oocyte function in reproductive medicine.
Mariano, sorry, you have to put slide into presentation form.
The slides are not in presentation?
No, not yet.
I don't understand why, because I just, sorry. Don't you see the slides now?
Yes, Professor, we see the slide, but it's not in presentation mode. So if you can click on the right side of the PowerPoint presentation, the left side, please.
Yes, but I am in new slide. What is the... What is the...
Reduce at least the list of slides on your right, on your left, in order to enlarge the screen.
Let me to see how to do that. There is some on the right, you say?
On the left side, Professor. On the left side of the PowerPoint screen, you can press presentation mode.
So yes, I see. Presentation. Yeah.
From the second one? No, not this one. Dalla diapositiva corrente.
Okay.
Okay.
It's working now?
Thank you, Professor.
I beg your pardon.
You have 20 minutes. Bye, go.
Well, I will be in hurry, of course. Okay, so this is just to introduce the work that is ahead of us. Some key biochemical and physiological features of inositol, as you know, is a polyol with 9 naturally occurring isomers, and at least 2 are very prominent for a medical point of view. As I said before, inositol and dichiroinositol. What is important is, however, is to put in a phylogenetic perspective the role of inositol. We just published a paper in which we demonstrate that inositol play a key evolutionary role in distinguish between prokaryotic from eukaryotic cells. We published this paper on computational biology, in which we demonstrated that the diversification of inositol role are instrumental in order to modulate, in order to drive the the trafficking in between plasma membrane and the outside environment, as well as the signaling between the cytosol and the nucleus, as well as the signaling between cytosol and mitochondria. What is the message? The message is that inositol, from an evolutionary point of view, has a critical role in governing all the process that imply, let's say, a transduction of a signal in between different compartments, namely between the internal states and the external one. The external considered as the, let's say, the cell environment, as well as the environment outside the nucleus. This is a very prominent feature because it explains why inositol and its derivatives are so important in modulating a number of signaling processes. And this kind of study has been performed by analyzing through computer simulation all the components of the cells, spanning from the very, let's say, the very simplest one, like bacteria and fungi, to the metazoan and the mammalian ones. As you know, we can, for a while, inositol has been deemed a B7 vitamin, a component that that is absorbed mostly through diet. And in a great part, inositol is provided by the good catabolism of the inositol hexaphosphoric acids, the phytic acids. And as you know, from the 70s, the utilization of phytic acids has been forbidden in European country because phytic acids demonstrate a relevant chelating activity against a number of trace elements, including iron, but also nickel. This is very important because the chelation of nickel can prevent a number of diseases related to nickel absorption. However, this kind of chelation capacity has let's say, a medical relevance only for undernourished, for malnourished population, where the almost 16% of all the food is provided by cereals, while in a European country this kind of problem can be safely overlooked. And an important problem that has been clarified only during the last years is how the inositol is absorbed from the gut. We have two transporter, the transglutamic transporter, that is a simple device. I mean, is utilized the gradient provided by different concentration of sodium to actively uptake the inositol, while the GLUT2 uniport does not utilize this kind of gradient. It's important to outline that for the uptake of inositol, as we will see later, inositol is actively is counteracted by glucose. And what is more important, the addition of lactoalbumin can significantly improve and raise the level of inositol that can be absorbed by the gut. Mostly inositol so is provided by the degradation of phytic acid, and we have also minimal absorption of more complex molecules like phosphatidyl inositols. and the inositol is then transferred through the general circulation into the blood, and in some tissue is actively concentrated, like in the central nervous system, where the concentration are generally of 2 or even more order of magnitude higher than that in the blood or in other tissue, while the catabolism is mostly provided by the kidney. As I said before, for a while it was considered deemed as a vitamin. However, we know now we know that from the glucose 6-phosphate, inositol can be produced in mammalian cells as well as in yeast. In yeast, the gene responsible for the synthesis of the enzyme that will transform glucose into inositol is known as INO1, while in mammalian cells, the critical gene, as we will see later, is the INO1. So we can produce, depending on the bioavailability and the need of the organism, in between some confidence limits, the organism can synthesize by itself the inositol it requires. Very briefly, we start with myo-inositol. The myo-inositol is subject to some conversion, some spontaneous conversion or conversion mediated by specific enzyme like epimerase into D-chiroinositol in the tissue, and the distribution of different isomers is tissue dependent. Myo-inositol is at first used for building phosphatidyl inositol. The first brick, the phosphatidyl inositol, is also the, let's say, the generative brick of 2 other very important molecules, including the inositol 3-phosphate, while through further addition of phosphate group by different and specific phosphatidyl kinases, the phosphatidyl inositol will give rise to specific phosphoinositides. I mean, phosphatidyl inositol phosphate 1, 2, and 3. These phosphoinositides can be also converted by the association with a glucosyl group into glycosyl phosphatidyl inositol. These are bricks, these are blocks that are members of the cytosol membrane. They have a very relevant place in our narrative, as from the glycosyl phosphatidyl inositol, the organism is able to synthesize inositol phosphoglycans, including both myo-inositol moiety as well as dichiro moiety, as we will see. 2 important signaling molecules that participates in the transduction of insulin signals. Very briefly, the inositol catabolism is mostly occurs mostly in the kidney, where it is usually in normal condition, almost completely metabolized into glucaric acid. We will see the role that this kind of metabolites play in explaining diabetic nephropathy. The intracellular conversion of inositol into a number of active intermediate and active metabolites is a challenging task, is quite complicated. I beg your pardon for these slides. we have no time to discuss in detail, but let me just to outline some key steps. The first is the synthesis of, of phosphatidyl inositol, the phosphatidyl inositol phosphate 2, because the PIP2 is, let's say, the how can I say, the warrior of the membrane, is modulate the traffic of a number of substances as well as of endocrine factor. Then we have the from the PIP2, the metabolite can be switched from the production of inositol 3 phosphates and or otherwise into the synthesis of a PIP3. The PIP is a transient feature of the cells because it's readily metabolized. And as you know, this step is catalyzed by PI3 key, phosphatidyl inositol 3 key, that is a cornerstone in the cancerogenic process. From inositol 3 phosphate, we can, let's say, the fate of this intermediate metabolite can follow the way to reconstitute, let's say, the original inositol, while another process lead to the production of inositol hexakis phosphates, and from there the synthesis of pyrrhose phosphate. Pyrrhose phosphate have been are received increasing attention in the last years, as they play a very critical role in motility, in cancer, and in metabolism too. This is a slide that will appear in a paper that will be published in a few days by the journal Molecules, in which one of my co-workers, Dr. Minini, demonstrate how we can modulate the motility and the viability of tumor cells only by down-regulating inositol phospho-6 kinase 1. And this can be obtained by adding inositol directly to the cells, and we study this process both in vitro as well as in vivo. Just to outline how is not enough to speak about inositol, but when we are dealing with this very, let's say, primordial brick, we have to consider the kind of metabolic conversion that inositol undergoes in the cells in order to appreciate what kind of influence it can have on many different critical functions. Why? Because we are now speaking about, let's say, about a code for the different phosphatidyl inositol phosphates that play a different and selective function in enabling the signaling transduction across different compartmentalized region of the cells, vesicles, Golgi apparatus, and so on. So they, let's say, in a synthetic way, we can address three main signaling networks in which inositol and its derivative play a critical role. The role play in the insulin signaling and more generally in metabolic governance of the cells, in governing cytoskeleton signaling, and in governing also chromatin remodeling and modulation of genomic signaling. This is in accordance with the finding I recall in the beginning of this talk, when I suggest that the evolutionary role of inositol is to modulate the trafficking of molecules and the signaling across different kind of membranes.
Mariano, excuse me, you have 5 minutes more, 7.
I recognize that is a very too complex question, so I will go directly only to one aspect because we have not the time to discuss in detail. Let me just to focus on one aspect of the inositol metabolism, and I mean the ovary. As you know, a paper from the group of Nestler evidences years ago that by adding D-chiroinositol in small concentration will produce relevant effects in polycystic ovary syndrome patients that were allowed to recover several reproductive function, but by increasing the concentration of D-chiroinositol, this kind of benefit disappear. So this led to the emergence of a so-called paradox, as was highlighted by a seminal paper authored by Vittorio Hofer. And the paradox is always an opportunity to make some progress in the understanding of the process. We know that chiroinositol is unidirectionally transformed actively by epimerase from myoinositol, and this occurs in a very different manner according to, let's say, a tissue dependence. So we have a different representation of D-chiroinositol in different tissue. And what is more important, D-chiroinositol is account only for a minimal portion of the inositol in the ovary, while in patients with insulin resistance or with polycystic ovary syndrome, the chiroinositol increase steadily. This has been also experimentally verified by a seminal paper authored by Lardner, in which we demonstrate that paradoxically, the epimerase in the ovary that is insensitive, let's say, the epimerase can be induced in all those conditions that imply an increased insulin release. And indeed, in the ovary, where the insulin is always effective, even in condition of diabetes, the insulin induces an increased transformation of myoinositol into D-chiroinositol. So we are facing with the paradox in the sense that myoinositol is defective in this kind of situation, while D-chiro is increased. Why this matters from a clinical point of view? Simply because, as stressed by a paper authored by Lamarca, D-chiroinositol reduce significantly, as you can see, the expression of aromatase. This implies that in ovary of PCOS patients, the aromatase account for even less than 50% of the normal value of activity. So the D-chiroinositol behave like an aromatase inhibitors. I already demonstrated in an experimental study, altogether with my friend Arturo Bevilacqua, that treating an experimental model of PCOS in mice, we were able to demonstrate that only giving myoinositol and the chiroinositol in the proper ratio of 40:1, we were able to restore the normal ovary function, namely by, let's say, correcting the theca granulosa layer ratio, as you can see from this data, in which the let's say, the normalization of the ratio between the two inositol isomers was able to normalize the histological findings, and also from a clinical point of view to recovering the ovarian and fertility function. We are now exploring how are the biochemical pathway that underlie this kind of results, and we have some preliminary data in which we demonstrate that myo-inositol can effectively blocks, inhibits the androgenic way that occurs mostly in T cells, while favoring the activation of the FSH-dependent pathway by normalization the ratio between androgen and estrogen in ovary from polycystic ovary syndrome patients. There are some open questions. I am going to my conclusion. We are planning new study in order to better grasp the complexity surrounding the diversification of metabolite transformation in cycle cells of inositol. This is the first question that should be addressed in order to put in a more rational basis the study on inositol. Pharmacokinetic and bioavailability of both the Dichiro and myo-inositol should be also more in depth investigate in order to establish proper protocol of treatment in a number of clinical situations, and this implies also to study the proper pathology, the combination with other natural compounds. I suppose that Professor Kamenov will speak about the utility to add lactoalbumin to improve the absorption. And finally, we have compelling data about the proper ratio in between myo-inositol and Dichiro, but we have to improve even more with a more extensive randomized clinical trials in order to gain further insight into this very complicated question. I beg your pardon to be even more delayed in time, and I thank you very much.
Thank you, Mariano. You reach, in effect, much more than the time you assigned was. However, I leave just one question for you because it's interesting for all the audience, and it comes from Ina Nadim, which would know what's about toxicity, signs, and symptoms of inositols. Have you an idea to answer to this question?
Yes. Very simply, we have very significant data that demonstrate that even by treating patients with higher doses, up to 30 grams by day through intravenous route, we recorded no side effects at all. In very few cases, we have recorded some situation in which diarrhea occurs. But actually, inositol has no RDA, no dietary recommended allowance, so it should be considered completely safe.
Okay, thank you very much. I hope our colleague is satisfied. And now I go on and I move on my next lecture, which is about inositol for the treatment of PCOS. Could I have my slides?
Would you like me to share the presentation?
Yeah, thank you.
Okay.
Meanwhile, we have reached more than 600 participants, and I'm very happy of this. Let's say we will discuss in my presentation something about the clinical use and the clinical relevance of inositol treatments. Now you have understand why I put a turtle in my presentation, because the inositol molecule in the space has been parallel to that of a turtle. So we move on. Could I move myself or? It's not okay. Thank you. The story, in brief, in 5 minutes, I would like to resume all the story of about we understand about PCOS, and we start very far. You say from 1921, when Archard and Thierse described a diabetes in a bearded women, and this some interesting observation parallelize metabolism problem and hirsutism. But we have to go through to Stein and Leventhal, we have to go through Stein and Leventhal because through pathological findings, they make another correlation. They make a correlation between a menstrual cycle disorder like amenorrhea, which was associated with some peculiar presentation of bilateral polycystic ovary. You could see here their glasses when they demonstrate the presence of the polycystic ovary. At that time, we are still on 1935. And we make a big jump and we go on on 2003, when at the beginning of this millennium, after many disputes about the etiopathogenesis of PCOS, and since such disputes does not arrive to a final point, in Rotterdam, a lot of researchers and scientists decide to be more pragmatic and to describe PCOS as their clinical signs and symptoms appear, so including oligoanovulation on one hand, clinical and or biochemistry, hyperandrogenism, and the polycystic ovary itself. So when 2 out of these 3 criteria are met, we could classify a woman on a PCO syndrome. And this at least allows to the fact that on our scientific papers, we speak all around the world the same languages. And later on, there was just a small but significant increase from my point of view, because when we try to describe the different, there are 4 phenotypes of PCOS, where anovulation, hyperandrogenism, and PCO are mixed, each one with the other in different phenotypes. For the first time, the international organization acknowledged the issue of metabolic risk, because as it is important for me and for all the women in the world that suffer of PCOS, is that we have to face a women that in fact share many symptoms and many biochemistry of so-called metabolic syndrome. As you could see from the slide, the prevalence in the general population is 6.1% of metabolic syndrome. And if they look at PCOS with whatever diagnostic criteria is used, the situation, the prevalence of metabolic syndrome in those subpopulation is around 10. Therefore, we could ascertain that PCOS subjects carry a 2-fold increased risk of metabolic syndrome. But it is not only this. We have also to acknowledge that they displayed a 5-fold increased risk to develop type 2 diabetes lifelong, which means that when we have in our clinic a woman with a PCOS, we have to bear in mind also this complication of her life later on. And this introduced the fact that one of the few agreement that have found among many different researchers and scientists around the world is that the insulin resistance is the mainstream of the PCO condition. Insulin resistance allow hyperinsulinemia, and hyperinsulinemia through different mechanisms, the lowering of sex hormone binding globulin, the increasing of ovarian androgens production, the disordering of LH, FSH release from the pituitary, allow for the symptoms that you are normally seeing in these women, which are hyperandrogenism on one hand and anovulation on the other. Insulin resistance is easy defined. In order, look at the panel in the bottom, in order to reach a normal utilization of glucose, so in order to maintain glucose level in a homeostatic situation, we need much more release of insulin than in normal condition. And this means that these women, these patients, are prone to later on develop and stress all the metabolic system and then to undergo to a chronic situation like the metabolic syndrome and diabetes mellitus type 2. And just to have an idea what's about insulin sensitivity is in normal women and in women with PCOS, this data from DUNAIF reported us that if we have a normal lean patient and respect to this one, a normal lean obese patient has a lower insulin sensitivity, which is nearby and parallel those of an PCOS women, lean PCOS. If in addition to a PCOS, we have also obesity, the insulin sensitivity is further decreased and is absolutely superimposable to the one reported in people suffering of type 2 diabetes. That's why we told about inositol tonight and their effects in PCOS. Inositol is an insulin-sensitive agent, and the increase in insulin signal is obtained directly activating the GLUT4 in the cells, or also through de novo lipogenesis and a reduced fat, so the activation of free fatty acid. The main results is an increase in insulin sensitivity, as it was demonstrated in a series of elegant experiments by Soulage in France. Mariano reported this slide, and we are speaking about these two compounds, which are very, very similar one each other, you could see from their formula. And these two compounds are the most significant one and are the most interesting one as far as PCO is concerned. It is important to remember that once myoinositol is activated by the epimerase enzymes, is transformed into dichiro-inositols. But this conversion is unidirectional, is not bidirectional, and depends on insulin. So the highest are the insulin level, the highest will be the conversion from myoinositol to dichiro-inositol. And dichiro-inositol and myoinositol act as second messengers in the cells. The main message that they drive is those of insulin, but it is interesting also to know that inositol also is involved in the message of FSH and in a lesser measure of TSH. Just to understand how biochemist is related to function, this is the panel and the experiments made by Larner, and you could appreciate that the presence, the significant presence of dichiro-inositol in the tissue is just on those tissue in yellow where there is a glycogen store. So in the fat, in the liver, and in the muscle, where is the accumulation of energy, the storage of energy, dichiro-inositol is significantly present, let's say in a ratio 3 to 7, 4 to 7. In all the remnant tissue, in the blood, in the kidney, in the intestine, in the spleen, and so on, there are almost negligible amount of dichiro-inositol present, while the main part of inositol is represented by the myo-inositol. And the same occur also in the follicular fluid. In fact, measuring in the general circulation of healthy young volunteers, women and men, you could see women in follicular phase, of course. You could appreciate here that in different studies, we ever reported a stable evaluation of the two concentration, the relative concentration of myo-inositol and the ones of dikir-inositol, and they are around 40:1. That's why in many publications we consider this the so-called physiological role of myo-2-dikiro-inositol in our body. And it seems that something is wrong in the PCOS. So it seems that myo-inositol and dikir-inositol play a pathogenetic role in the context of PCOS women. Because if you look in the follicular fluid of those women, you could see here very easy that there is an excess of dikir-inositol in the follicular fluid of women with PCOS respect to the healthy non-PCOS population. So there is an excess of dikir-inositol in the ovary of these women. And the other experiment, which is most important, is if you put the TICA cells from the ovary and you took these TICA cells from normal and PCOS human, the conversion from myo to dikir-inositol, which I remember you, it's unidirectional, is much, much more increased in terms of conversion in women with PCOS. And this allowed the fact that they have much more dikiro respect to myo-inositol in their ovary. So in some way, the machinery that undergo to the metabolism and the activation of myo and dikiro-inositol is deranged in women with PCOS. And it's against the fact that these women has need dikiro-inositol. These women has need to decrease dikir-inositol, not to increase dikir-inositol. And so let's go into the clinical evidence. We performed with Vittorio Unfer and the co-worker and also assisted by John Nestler, which is the first one who discovered the activity of inositols in women with insulin resistance. And we performed a meta-analysis and a systematic review of the inositol effects reported in clinical trials. We recognized at that time, so it's 2 years ago, 9 clinical trials with 250 people, 250 women in each arm of the trial. The primary outcome of our meta-analysis was the effect on fasting insulin values. And we have also other secondary outcomes, which are HOMA index, the insulin resistance index, test androgens levels, as well as sex hormone binding globulin levels. So look briefly at this meta-analysis. You could see here easily how our primary outcome was demonstrated in this meta-analysis. The treatment with inositol arrived to produce a significant decrease in insulin levels, in fasting insulin levels. And let's say consequently, perhaps, but in any case, as an independent evaluation, also the HOMA index is reduced. And this is the most important demonstration of inositol as sensitive insulin agents because they reduce insulin resistance. The effect on plasma androgens, testosterone and androstenedione are not significant. You could see the diamond, the green diamond, which cross the line of 1 in both panels, while an interesting evaluation was done on sex hormone binding globulin. We divided the trials in 2 different ways according to the length of treatment. And if you see that if you administer inositol for just 12 weeks, you do not change anything, which is the first diamonds in the top. While if you proceed with the treatment and you enlarge the treatment for 24 weeks, then you obtain an increase of sex hormone binding globulin, which means a reduction in free androgens, in free testosterone, namely, and therefore a reduction in hyperandrogenemia also from a clinical point of view. Not only this, another researcher did an evaluation, a meta-analysis on the lipid profile during inositols treatment, and you see from top to the bottom that total cholesterol, triglycerides, and LDL cholesterol are all significantly decreased by the administration of inositols, while no impact was obtained on HDL cholesterol. And this means that not only endocrine situation changes, but also the lipid profile changes. And all these effects are in the same way as being very helpful for the metabolic syndrome treatment. Of course, we have obesity, and obesity is an additional further complication to this situation, because the adipose tissue is a very active metabolically organ. So this means that if we have 10 or 20 kilos more of fat, our insulin resistance is much more in addition to the previous insulin resistance already present just because of the polycystic ovary syndrome. And this makes up an issue because there were increased androgen levels, reduced SHBG, altered menstrual cyclicity in women that, being PCOS, are also obese. What are the effects of the addition of mayo and D-inositol? We had a few small experiments in this way, and it reports on the fact that if we intervene not only with mayo-inositol, but also with the combination of mayo and D-inositol, we arrive to reduce free testosterone levels much faster than it occurs with mayo-inositol alone. So the effect at the end is the same, but we obtain a much faster effect using the combination of the two. Since in many parts of the world, and the audience tonight would confirm this, I suppose there is an important use of another insulin sensitizer, which was the first one, which is metformin. I performed a meta-analysis of the only 6 studies that are until now published, and comparing the two, so metformin and inositols. And you could see here, this is just an abstract of all the meta-analysis. All these lines represent a different outcome. And so HOMA index, testosterone, androstenedione, SHBG, and BMI changes under metformin are absolutely superimposable to what's happened to those during mayo-inositol treatment. So the effect of metformin and mayo-inositol on this kind of outcomes are absolutely similar. They had equal efficacy. The difference between the two is that if we compare metformin and mayo-inositol on side effects, the tolerability is of paramount importance, is much different, because there is a 5.17 relative risk ratio to has a gastrointestinal or other side effect using metformin rather than using mayo-inositol. And this is in the experience of everybody, every one of us that uses these two compounds, that we had many women that put once in metformin treatment, they abandon this treatment. They skipped out because of these side effects. And this is certainly an atu of inositol for our purposes. In fact, just to answer the question that was about toxicity, here there is just a few of the studies that are reported in literature where 4 grams a day, 6, 12, until 30 grams a day of inositol in a situation of obsessive compulsive disorder have been used in humans without almost negligible side effects, apart from small nausea, flatus, and diarrhea. But all these main side effects arrived and have been described only with doses highest than 12 grams a day. Mariano already reported a lot of panel like this, and I have really difficult to follow exactly. This is just to read the first words in red. Myo-inositol enhances the FSH signal, and this could have an important impact on the ovulation, as you can see later in the next slide. We know for more than 20 years ago that insulin levels are a problem where we try to induce ovulation. At that time, we have had the experience of the first controlled superovulation, ovarian superovulation, and in the group of Frank in London demonstrate this good correlation. The highest are the fasting insulin levels, the more we need in terms of vials of FSH to induce ovulation. So insulin levels counteract the ovarian responses to FSH. And based on this observation, many people in the world try to perform different trials, and you could have here a meta-analysis of those trials. These trials reported more or less the pre-treatment for 3 months and the months of controlled ovarian induction before the IVF or ICSI. There were 6 randomized controlled trials reported in this respect, and the results are this one. The first is that we need less vials of recombinant FSH to obtain ovulation. In particular, according to the meta-analysis, we need less 3 vials of FSH. But this is not really important. This is just a demonstration that the experiment performed in London 20 years ago have a good impact on our day-to-day activity. The most important efficacy of the pre-treatment with inositol in assisted reproduction is that we obtain a 45% increase in the risk of a clinical pregnancy rate, which means an important addition and an important help to our performance in terms of reproduction. The importance and the impact that the two Mayo and Dikiro and their ratio has on ovulation is reported in this recently published paper, where the authors, you see, experimented different ratio from Mayo to Dikiro, starting on the left from only Dikiro inositol to the left part or almost only Mio, just 80 Mio and 1 part of Dikiro. And you could see here that this is the progesterone levels measured at the first, at the second, and at the third cycle of observation. You see that only with 40:1 and 80:1, we have an important secretion of progesterones indicating ovulation being in that women. On the other hand, the insulin resistance through HOMA index improved with every one of this treatment. And this makes the difference between the metabolic effect, which is obtained with both Mayo and Dikiro inositol, and the reproductive effect, which is obtained only with the combination where Mayo inositol is at least 40 or 80:1 present respect to Dikiro. I go on, and these are the take-home points that I would leave tonight. Insulin resistance, we understand, is the main driver of PCO syndrome, and thus insulin sensitizers represent an etiological-based intervention. This is an important piece of work. Similarly to metformin, we have seen, clinical trials established the efficacy of inositols in improving endocrine and metabolic disorders of PCOS patients. Inositols, however, are much better tolerated than metformin. And finally, an excess dichiroinositol seems to characterize the ovary of PCOS women. Therefore, myo and dichiroinositol in an appropriate ratio like 40:1 improve ovulation, and such combination increase the performances of assisted reproduction. So I thank you for your attention. I took now note of some of your questions, and then I will answer it later on. And or even if we would have if I read, because it's not easy for me, if I read good, it is Umar Shesad, which asks, if the concentration of DCI is increased muchfold in ovarian cell during PCOS, then how is possible that DCI from blood transfer into the ovarian cells and transfer follows passive? This is a very complicated biochemical question, but many things that we believe in our mind are not so in the reality. And therefore, I stay on the pragmatic evaluation that if I use much more dichiroinositol in women with PCOS, I obtained a worse performance in terms of ovarian activity, because in terms of metabolic activity is different. You have to remember that ovary is never insulin resistant. It's not a tissue like the hepatic cells or the muscle. That's perhaps the answer. So let's say I speak very, very long, and I would like to have the intervention now of Zdravko from Sofia, which will speak about the other common issue in the inositol therapy, the alpha-lactalbumin. At the end of his presentation, there will be 1 minute or two for specific question, and there I will open a general discussion. Thank you very much, Zdravko. It's up to you.
Hi, Fabio. Hi, Mariano. I'm so glad to see you and to hear you. Very interesting lectures. Hi, everybody. I'm really glad to be together with you during this webinar. I'll talk about our coming issues in the inositol therapy, the alpha-lactalbumin. And this is the agenda. First part of my lecture will be devoted to inositol resistance. I remember 2013, the International Consensus Conference on inositols in obstetrics and gynecology. We put several questions, obstetrics and gynecology and assisted reproductive technologies. A paper came out focused on twin metabolic syndrome and PCOS, and as already Fabio and Mariano mentioned, treatment with inositols reduce insulin resistance, hyperandrogenism, hirsutism, and acne, and restores hormonal balance and metabolic. The assisted reproduction technology, and it pointed out that inositol therapy restores ovarian function by inducing ovulation and improved oocyte quality, embryo. So 5 years recently, this expert opinion on inositols in treating polycystic ovary syndrome and non-insulin-dependent diabetes mellitus.
Zdravko,
the evidence suggests that
Zdravko, excuse me if I interrupt, but because your voice it's not really stable. Try to be more near to the computer and to check for your line. Thank you.
Okay, how it is now?
Okay, it's good.
Okay? Good. So, And my topic now will be about one of the updates, which includes the new evidence on the efficacy exerted in the PCOS 42-1 Mayo-to-D-Chiro, the innovative approach based on alpha-lactalbumin to overcome the decreased therapeutic efficacy on inositols in some patients. So we already know that Mayo alone or Mayo plus D-Chiro improves insulin sensitivity and improves oocyte quality. But as you know, in this famous movie, nobody is perfect. So around 30 to 40% of the patients are do not ovulate with Mayo, and we call them Mayo-inositol resistant. What is the problem with this? We know that the homeostasis of Mayo-inositol, it was pointed out just before me, depends on the intestinal absorption, carrier-mediated transportation, endogenous synthesis and catabolism, and kidney excretion. So inositol deficiency may be caused by decreased biosynthesis and or transporter activity. We know that there are two types of transporters, the sodium and the proton coupled, and only SMIT2 is found in duodenum and jejunum. Also, it may be caused by inhibition, competition of intestinal and cellular uptake by different interfering agents. For example, D-chiro-inositol has a lower Michaelis constanta than Mayo, and this means higher transporters affinity. So it's very important not to give too much D-chiro-inositol because it will interfere with the transportation of Mayo. And glucose, it has 100 times lower transporter affinity, so it cannot cause problems. But if there is a huge amount of glucose, then it could also happen. Very important are the abnormalities of intestinal absorption due to chronic inflammatory states and reduced food-dependent intake and increased catabolism or excretion. So as you can see, most of the mechanisms already mentioned as probable for inositol deficiency are related to the gut. And we have a very good Mayo-inositol and D-chiro-inositol option for improving the PCOS patient conditions, but we of course have to do it even better. And as Henry Royce said, strive for perfection in everything, take the best that exists and make it better. If it doesn't exist, create it. Accept nothing nearly right or good enough. So the second part is about the gut microbiota and the metabolic syndrome. Today, we live in the civilization of obesity and diabetes. This is because it took 5,000 generations to become a human being, and then only 5 generations to become a Homo McDonald's or Homo computers. So the circumstances have changed, but our genetics did not. And today we have the metabolic epidemics. It is not the simple link between more food and more fat. There is also a missing link, and this is the gut microbiota. Gut microbiota means all the bacteria we have in our gut, and the microbiome means the genome of all these bacteria. It is only one part of the many microbiome in the skin, vagina, etc. We live with this bacteria. It's normal to have them, but they have to be in a very good proportion. So we have 10-fold more bacteria in the human gut compared to our cells, to eukaryotic cells. And at birth, the gut of a neonate is still sterile, but quickly becomes colonized by the bacteria derived from its mother's birth canal, the external environment, and the food. There are about 1,000 different bacterial species in the adult bowel, and the dominant are Bacteroides, Firmicutes, and Actinobacteria. The global interest to gut microbiota increased starting somewhere at the end of first decade of this century. And this is because the obesity and diabetes pandemics, surgical treatment of obesity and diabetes, and GLP-1 receptor agonist treatment of diabetes and obesity. Gut microbiota has a very important role, physiological role. It is important for the synthesis of vitamins. It makes the protection, immune system development, promotion of intestinal angiogenesis, promotion of fat storages, short-chain fatty acids production, and modulation of central nervous system. So gut microbiota related are very important processes like the control of appetite. In the arcuate nucleus, here are the agouti-related protein, and also the CART, cocaine, amphetamine-related peptide, propiomelaanocortin, etc., centers for hunger, for satiety, etc. Another mechanism, this is the neural mechanism. The gut has very good developed neural system, and through the vagus nerve, the vagal afferent nerves, it affects the nucleus tractus solitarius, etc. But gut open for the immunity and inflammation. You see here the microbiota and many other cells from the immune system which are affected, stimulated, or suppressed. There are many diseases which are linked to gut microbiome and this cardiovascular disease. We know that atherosclerosis is a low-grade inflammation condition. Also central nervous system, Alzheimer, etc., IBD, etc. disease. This is a very interesting Chinese study. They characterize the gut microbiome composition of 655 twins, mono and dizygotic and their families, and about 18% of them had metabolic syndrome. They related to lower gut microbiota diversity and abundances of several taxa like Suterella, Metano, Brevibacteria, and Lactobacillus. And protective were the Akkermansia, Odoribacter, Bifidobacterium, but they were decreased in the patients with the metabolic syndrome. And they found also that the Bifidobacterium deficiency has highest heritability. So they concluded our results suggest that an altered microbiota composition mediated by a genotype can contribute to the development of metabolic syndrome. This is a very short scheme. Everything starts with high-fat zinc or other aspects of the Western type diet. There is a change in gut flora, increased permeability, increased lipopolysaccharide absorption, and this is a toxin, increases endotoxemia, inflammation, and causes the metabolic disorders. So through the diet, age, lifestyle, genetic, antibiotic usage, we may cause dysbiosis of gut microbiota, and this may cause further obesity, IBD, diabetes, cancer, and autism. This is not a privilege of the humans. Also in the insects, we can talk about the metabolic syndrome and their gut microbes, and also in small mammals like mouse. Gut microbiota, this is an ancient time bomb for the metabolic syndrome, and this has to be taken into consideration. The most important, this is our lifestyle and what we eat. The third part is the dogma hypothesis. This is a new piece in the pathogenetic puzzle of PCOS. Nothing new. Hippocrates, 410 years before Christ, wrote in the Scientias, the causes of bareness in the women are the fatness and moistness of their flesh, which are such that the womb cannot absorb the seed. Their monthly purging is scanty and late, while the mouth of the womb is closed and does not admit the seed. They are personally fat and lazy. Abdomen is cold and are the causes. These are the causes which make them unfertile. And now, a clear proof is afforded by their slave girls. This because of their activity and leanness of body. No sooner go to a man than they are with child. In his famous Banting lecture, Revan positioned the PCOS in the so-called X syndrome, and this is the prototype of the metabolic syndrome by Fabio about the pathogenesis, the role of hyperinsulinemia, hyperandrogenemia, insulin resistance for all these diseases. And we know today that there is something more, and this is the microbiota and the inflammation, which should be included in the pathogenesis of the PCOS. So we know that microbiota is important for the development of PCOS. I'm sure there is also existing the opposite link, but it is much less studied. And we talk today about the dogma dysbiosis of gut microbiota. There is a reduction, proven reduction of alpha diversity, increase of lipopolysaccharide production bacteria, decrease of spore-forming species. So you see that all the aspects of development of the metabolic syndrome related to gut microbiota are also present in most of the, I shouldn't say in all, but in most of the PCOS women. And PCOS is linked to a leaky gut. Inflammation causes hyperandrogenism. In our group, we studied many different markers, organokines, adipokines, hepatokines, myokines even. For example, myeloperoxidase, monocyte hemoattractant protein, factorin A, antiprobin B, etc. In women with PCOS, showing that they are at increased risk, but this was just mentioned by Fabio. And today we have a new piece in the puzzle of PCOS, and this is the gut dysbiosis. I'll talk about myoinositol and alpha-lactalbumin, and you see that human milk, this is an orchestra of benefits, and here is also the microbiota effects. Alpha-lactalbumin, it is a milk serum protein. It is 40% of human colostrum, but it is around 20 to 30% of the human milk proteins. And you have to mention that it is the percentage of alpha-lactalbumin is much higher in human milk compared to the bovine milk. And human milk has much less protein compared to cow, goat, and sheep. Much less calcium, much less phosphorus, but much more carbohydrates. And here is again the proportion. 88% of the human milk, breast milk, is water, and these are the other ingredients. I tried to find I made review in the PubMed about the alpha-lactalbumin, and more than 4,000 results were found. The first one, the lactalbumin, was in 1896. Can you imagine what about was this first paper about obstetrics and gynecology and Worcester method of rendering cow's milk, which is believed to be poor in lactalbumin, as nearly as possible and equivalent for mother's milk. This is from Boston Medical and Surgical Journal, more than 1 century ago. And here you see that there is a steep increase in the interest to lactalbumin. Why? Because in this paper from 1966, they wrote alpha-lactalbumin, a major constituent of the whey protein of milk, has been recognized for some 20 years, though no biological function other than a nutritional one could be ascribed to this protein. The present results suggest an enzymatic role of alpha-lactalbumin as one of the subunits of lactose synthesis. And further on, 4 years later, again about this enzymatic function, some experiments were made. So today, most of the infant formulas contain alpha-lactalbumin, and it is included by the FDA in the list of generally recognized as safe GRAS substances. So this is very important, and this means it is safe. Alpha-lactalbumin is used by the bodybuilders. Its synthesis is induced by prolactin. It's highly thermostable. Its main function is to induce the lactose synthesis in the breast milk as protein B. It has a bacteriostatic activity, mainly gram positive, and antiviral functions. Furthermore, it is a prebiotic, mucoprotective, anti-inflammatory, immune modulating, and trophic. There are many papers. I have no time now to focus on the many papers showing these options for alpha-lactalbumin. So PCOS is linked to gut microbiota alterations, and it is an inflammatory status. ALAC restores the flora, thus improving the physiological nutrients absorption, and it has reduces inflammation and consequently the hyperandrogenism of PCOS. ALAC is very rich of tryptophan, and tryptophan is the base amino acid for melatonin, and we know that melatonin is very important for many aspects of the reproductive function, especially for the follicles, and also ALAC is poor in ALAC is also a carrier for vitamin D and for divalent metal ions like calcium and iron. So we have the myo-inositol and we have the ALAC. Small things make perfection, but perfection is not a small thing, as Henry Royce said. And what about the combination of them? Much was insulin sensitizing, FSH sensitizing, and many other functions, positive functions. But ALAC is also anti-inflammatory, melatonin synthase inducer, and improves nutrient absorption. So there is a very good combination. It's synergistic between myo-inositol with the effect on insulin resistance and ALAC with the effect on inflammation and microbiota alteration. Finally, I'll show you two papers which I consider very important. One of them is the paper of Giovanni Monastra. It's only with 18 healthy patients, 7 men and 11 women, but it has to show the effect of alpha-lactalbumin on myo-inositol intestinal absorption in vivo and in vitro. They were able to show that the area under the curve, when using compared to the curve with myo-inositol only. And also the Cmax was 30%, 32% higher here at this point compared to the myo-inositol only. So ALAC improves the myo-inositol absorption. It's very important. Without changing the pharmacokinetic, the maximum comes here on the 180 minutes. But actually, is it the actual mechanism, the improvement of myo-inositol absorption? They continue to the very important part. They use the CACO2 cell line, and this is the best available model for small intestinal mucosa. CACO2 cells make monolayer on the permeable polycarbonate filters. So this mimics the enteral wall, the enterocytes. They use the transepithelial electrical resistance. This is a measure of the transportation, and also phenol red passage, again a marker of transportation through this monolayer of CACO2 cells. They applied in 2 concentrations, 5 milligrams per liter and 10 milligrams per liter. And what they found is, you see, this is the myo-inositol transportation when the myo-inositol was applied only. This is the combination with 5 milligrams per liter, and this is the combination with 10 milligrams per liter concentration. It was much higher. So the higher concentration of ALA transported or helped in transportation of myo-inositol much more compared to the smaller one. And this is one of the conclusions. You should use enough alpha-lactalbumin in order to have the effect. And these are the other effects, this transepithelial electrical resistance. The higher the resistance, the less the transportation through this model of a membrane. And you see with myo-inositol, with the small dose and with the larger dose, 10, it was much higher. So the higher dose caused an increased transportation. This is a proof that exactly the transport through the enteral wall is the effect of ALAC. But also the phenol red passage was able to show that there is an opening in tight junction between the cells, but it was not a continuous one. These tight junctions were opened for a special period of time and then closed again in order to stop the permeability of the gut wall.
Zdravko, please conclude.
Yeah. Okay, 1.5 minutes. So they concluded better myo-inositol absorption when orally administered with alpha-lactalbumin can be beneficial in non-responder patients. Preliminary in vitro findings suggest that peptides deriving from alpha-lactalbumin digestion may modulate tight junction permeability, allowing increased absorption of myo-inositol. And the second paper, this is the paper of Mario Montanino Oliva. In 2 phases, in first phase, they gave their patients only myo-inositol to 37 patients for 3 months. And in the second patients, those of them who are myo-inositol resistant took myo-inositol plus 15 milligrams of alpha-lactalbumin twice a day. These are the inclusion criteria, exclusion criteria, and the primary endpoints were restoration of ovulation, in myo-inositol resistant patients and increase of myo-inositol plasma levels in myo-inositol resistant patients. These are the levels of myo-inositol in the responders. They are 2 times higher in the myo-inositol not responders or resistant. So those of these women who had higher levels of myo-inositol, they ovulated much more. And in the second part, the women who were myo-inositol resistant with 17 micromolar per liter myo-inositol plasma levels increased twice their levels by alpha-lactalbumin. There were many other benefits from this treatment related to total cholesterol, triglycerides, testosterone, free testosterone, dehydroepiandrosterone, and SHBG. All of them were improved. And I can conclude that myo-inositol resistant patients show a lower myo-inositol plasma level than non-resistant ones after myo-inositol treatment. The combination is able to induce ovulation in the myo-inositol resistant patients, resistant to myo-inositol alone, and alpha-lac seems to increase myo-inositol absorption. So this is the clinical proof of what Giovanni Monastra was found in his in vitro experiments. And this is my last slide. The further you progress, the higher the ideal for perfection toward which you strive arises. So we'll see what will be the next step. Thank you for your attention.
Thank you very much, Zdravko. There are no shaking hands. However, you could imagine our hands shaking with your lecture and those of Mariano. Let's say I received more than 50 questions, so we cannot stay here for hours. As you can see here, the sun, or better, the sunset, already entered my office, and we have no so more time to stay with all the people which is on the web with us tonight. Anyway, I will try to summarize some of the questions, and the first one I offer the answer to Mariano. One of the repeated questions was, what's about overweight? Does myo-inositol better? Mariano.
The question is for me?
Yeah.
Well, in obese patients, you mean?
Yeah.
Well, I had no time to show the link in between inositol and metabolism. Very briefly, inositol is required to a proper balance in between gluconeogenesis, glucose storage, and glucose utilization. When you perturb this kind of pathway, you can assume that the extra intake of energy will be stored at fat. So reduce intake of inositol, and namely a troubled pathway of some key metabolites of inositol. I mean the inositol hexacetic phosphate and the inositol 6 kinases will alter in a significant manner the way the energy is used by the organism. Just one aspect. An increase in inositol 6 kinase will transfer the LKB enzyme into the nucleus and reduce the AMPK activity. So you know that reduction in AMP activity favor not only the, let's say, the kicking off of diabetes, but also of obesity. So it is important to restore a normal AMPK and this can be obtained by adding inositol, because inositol by itself is able to inhibit this the activity of inositol 6 kinase.
Thank you. Zdravko, 2 questions for you. A general one, because most of the people remember us, we do not speak about this, that diet, even vegan diet, could overcome metabolic syndrome. Would you answer on that, please?
Yes. Actually, I'm not expert in vegan diets.
No, but, okay, but in diet, in low carb, low fat diet.
Yeah. You should eat something. It's not possible not to eat fat and not to eat carbs. Then the question is what do you eat? But anyway, there are many substances which are very important in the general diet, especially, for example, polyunsaturated fatty acids, which could be also from vegetable origin. So, of course, if you don't eat so much calories, the most important here is the quantity of calories. Today, there are many different diets, low carb, low fat, high protein, etc. Some of these diets are not healthy. They may cause kidney damage or ketoacidosis, etc. Today, we think that the most important, this is the amount of the calories and the well-balanced content of ingredients in the diet you eat. So, the vegan diet decreases the risk for atherosclerosis, let's say, but there are many deficiencies which it may cause as well. So it should be very well controlled and it will be very well supplemented with the vitamins, minerals, etc., which are not included in the diet.
Okay, thank you. Remember, you know, like me, and I remember to the audience that unfortunately, any effort that we do for changing lifestyle and diet in our PCOS patients is very frustrating because they follow and adhere very poor to our advice. It's your opinion too, it's your experience too.
Yes, in the long-term perspective, only 7% of the overweight and obese people has weight loss. I mean, in the long-term perspective. So that's the reason we recommend normal caloric diet today, not very low caloric or hunger. You are right that it looks very easy, but actually it is very difficult to keep this new lifestyle. Who can do this, he or she succeeds in having a healthy lifestyle, but it is not easy. I completely agree with you, but an effort should be made. This is the basic for every
diet is the first things to do and to advise. Okay, I go on. There are one question that I could answer. Someone asked if I had women with PCO treated with inositols and then he become pregnant, she become pregnant. What's happened? It happens that you have to stimulate again the system, and so you have to supplement for the entire pregnancy with inositol because there are so many trials of our group that suggest how gestational diabetes is prevented if women took inositol early in pregnancy, let's say from the 10th week of pregnancy going on. Another question or other group of questions were about the dosage. I don't speak about dose. Normally, the normal dose is 2 grams myo-inositol or combination myo and dikiro in the morning and 2 grams in the evening because, and this Mariano could tell something, the absorption of myo-inositol is improved by lactalbumin, as you just report, but is also reduced by some other things. That's Okay, Mariano,
Yes.
please.
Yes, of course. Inositol uptake is reduced by a number of other polyols and other sugars like mannose, sucrose, sorbitol, and of course glucose. They compete with the same transporter. So inositol is in the inositol uptake is inhibited. For this reason, it would be better to take inositol in fasting condition in order to avoid any kind of interference with the absorption process.
Thank you. The question advanced more and more. We can stay all the evening here. However, there are some specific questions about alpha-lactalbumin to Zdravko, because they ask from which animal you took alpha-lactalbumin. And there is also one of our audience people that ask about a trial that he do on goat milk. Would you comment, Zdravko?
Yes, it's a cow origin.
It's a cow.
Yeah, it's a cow. We have to have enough quantity of it. So this is the origin. I don't know about. Of course, it exists in all mammals, but it's only a little bit different. It's not 123 amino acids in the mouse.
Okay.
It's a larger molecule. But anyway, this is the origin for the most abundant source of alpha-lactalbumin, which we can use.
Okay, thank you. Attendees also ask about how long could I treat a woman with PCOS with inositol or their combination? And the answer is not really scientific one. It's just depending on the need these women had and the goal that the doctor has to reach when treating with inositol supplementation. Anyway, we had the experience of some people for more than 20 months of treatment without any interference with her life. Someone of the panelists have some other experience, Mariano or Zdravko?
What is the question? May you repeat, please?
Yeah, how
you are not focused. Then Zdravko answer.
Okay, because I was replying to some of the question, you know.
Okay.
So
please.
I agree with you, Fabio. We have no limit for this, and I also have patients who have taken it for 2 or more years.
Okay, thank you. With safety, because the
yes, absolutely,
answered question is what about safety, but we are all, let's say, happy with the safety and tolerability of inositols. There are more. We arrived to 65 questions, and
can I add one consideration from the question that has been put in the chat?
Yeah.
We cannot forget that inositol directly modulate the steroidogenesis process in the ovary. This is the results of our study in which we demonstrate that inositol, by modifying the cytoskeleton architecture in theca and the granulosa cells, can directly, this is another mechanism through which inositol can modulate the switch between androgen 2 estrogens in the PCOS ovary.
Thank you for this observation, Mariano. And I, looking at the name that were associated with any question, I find here that we have an attendees from Brazil, I suppose, from the Caucasian Republic, from Iran, from India. I have seen also some people that I know personally, which attended the meeting from India. And there are also some other names that I cannot understand from which country they come, but from Turkey also, and from many others. So it was really interesting to share with all these people in the world our knowledge about inositol, PCOS, and etc., etc. They asked me to elaborate the role of inositol in GDM. Briefly, you could find papers on GDM and inositol on the American Journal of Obstetrics and Gynecology. I cannot stay now for any specific answer. We have also Indonesia. Very happy to know you from Indonesia. And let's say now is what time it is now is 1949. And I suppose our times should have expired at 1930. What?
We are still here.
Oh.
We are still here.
Can I suggest that people listening to the webinar can send the question, and so we can have the time to reply,
Yeah.
and even to attach some papers. There is a lot of questions.
Yes, there is a lot. If there, I don't know, I asked to the organizers if they has the mail of the people that ask questions, we could answer easy.
Yes, Prof.
Okay.
Yes, we
fine.
have, and we will inform everyone with the answers, no problem.
Okay, thank you very much. So everybody from Pakistan, Greece, Moldova, in the entire world is very, very, very happy to this. So you will have your question answered personally by the speakers once we collect all the questions. That's our promise. It's okay, Mariano and Zdravko?
Yes, of course.
Yeah, it's okay.
Okay,
Many thanks for the organizer and for the audience.
Now we have to thank the excellent speakers before, the excellent chairman, of course, those that help us in doing this webinar, so the technical activity and support by MCA in Italy, and first of all, also the unconditional contribution from Loli Pharma. Thank you very much to everybody. To the next. Ciao.
Bye.